the continuation of real numbers. Yesterday, we discussed the concept of non-terminating recurring decimals in rational numbers. Now we continue the concept. First, we note down a theorem statement and then we solve the problems on that one. Theorem 1.5. This is class 10 real numbers. Real numbers. Page 12. Page number 12. Theorem 1.5. Let x equal to p by q be a rational number, such that the prime factorization of q is not of the form 2 power n 5 power m, where n and m are non-negative integers. Then x has a decimal expansion. X has a decimal expansion which is non-terminating, repeating or recurring. So yesterday we did some problems, and for example we note down an example for this statement. Example: 1 by 7 equal to 0.1428571428557 and so on. This is equal to 0.1428557 bar. Yesterday we did the problem, and 1 by 3 equal to 0.3333 and so on. This is equal to 0.3 bar. So here what we have to observe is 7 is in the denominator. 7 is in the denominator, and this 7 is not in the form of 2 power n 5 power m. This is not in the form of 2 power n 5 power m. And here 3. 3 is in the denominator. So 3 is not in the form of 2 power n 5 power m. When a number x equal to p by q is given, and the denominator q is not in the form of 2 power n 5 power m, then we get a decimal number which is non-terminating recurring decimal, non-terminating and repeating or recurring decimal, non-terminating, repeating or recurring decimal. We did some problems based on this principle. So yesterday we did some problems, and based on those problems we can conclude this statement. If x is a rational number in the form of p by q, x is a rational number in the form of p by q, and it is not, q is not of the form 2 power n 5 power m. It is not of the form 2 power n 5 power m. Then we get a decimal expansion which is non-terminating, non and repeating or recurring decimal. For this, we can take an example 1 by 7. In the denominator, we have 7, and this 7 is not in the form of 2 power n 5 power m. It is not in the form of 2 power n 5 power m. So, we have got a non-terminating recurring decimal 0.142857 bar. And we consider another example to understand the statement of theorem. 1 by 3. 3 is in the denominator, and it is not in the form of 2 power n 5 power m. It is not in the form of 3 is not in the form of 2 power n 5 power m. So, what we understand from this is when the denominator q is not in the form of 2 power n 5 power m, then we get a decimal expansion which is non-terminating but repeating or recurring decimal. Now we can do some problems based on the earlier theorems. Using the above theorem, using the above theorems, without actual division, without actual division, state whether whether the following rational numbers, the following rational numbers, rational numbers are terminating or non-terminating, terminating or non-terminating repeating decimals, repeating decimals. So here the condition is that we should not divide. We should not divide without actual division. The statement is without actual division. We should state that whether the given rational number is terminating or non-terminating repeating decimals. So the first example is first problem 16 by 125. First problem 16 by 125. So this is equal to 16 by 125 means it is 5 cube. 125. 525 is 5 5s. So 5 power 3. So let this number is so 5 power 3 equal to 2 power 0. 5 power 3 is of the form 2 power n 5 power m. So then what will be the conclusion? Therefore 16 by 125 is a terminating decimal. We need not find the answer. That is, we need not simplify this. We should state whether it is a terminating decimal or non-terminating recurring decimal. It is a terminating decimal. Terminating decimal. So this is how you have to answer to the question. So first, let us discuss this. So the given problem 16 by 125. X equal to P by Q form. It is of the form X equal to P by Q. It is of the form X equal to P by Q, where Q equal to 2 power n 5 power m. So when the denominator is of the form 2 power n 5 power m, 5 power 3 can be written as 2 power 0 5 power 3. So it is a terminating decimal. So this is by theorem 1.4. Theorem by 1.4. So actually we have to write the statement of the theorem here. We have to write the statement of the theorem. And next problem is right. Next problem is 25 by 32. Second problem 25 by 32. Remember, we are considering so let x equal to P by Q, that equal to 25 by 32. This can be written as we consider only Q. We consider only Q, denominator only. We are not considering the numerator. The theorem 1.4, theorem 1.5 are considering only the denominator. We are not considering the numerators. We are considering only the denominator. So 32 16s to 8s to 4s to 2s. We can write this as 25 by 2 power 5. Now Q equal to, what is Q? 2 power 5. 2 power 5, that equal to 2 power 0, 2 power 5. 2 power 5, 5 power 0 is of the form 2 power n 5 power m, 5 power m. So when the denominator q is in the form of 2 power n 5 power m, we get a terminating decimal. We get a terminating decimal. Therefore 25 by 32 is a terminating decimal. Why? So based on this is using theorem 1.4. This statement is given by theorem 1.4. So students must refer to the statement of theorem 1.4 and theorem 1.5. 25 by 32 is given. So if the given number is taken as x equal to p by q, then 25 by 32, q equal to 2 power 5, we can write it. So 2 power 5 can be written as 2 power 5, 5 power 0. Therefore, the denominator q is of the form 2 power n 5 power m. Then by theorem 1.4, we can conclude that the given number x equal to p by q, that equal to 25 by 32 is a terminating decimal. Now we consider the next problem. Third problem. Hundred by 81. 100 by 81. Let x equal to p by q, that equal to 100 by 81. Now we find the prime factors for q. We consider the denominator q only. We don't consider the numerator. We have to consider the denominator. We have to check whether it is in the form 2 power n 5 power m. So 81, 3 27s, 3 9s, 3 3s. This is equal to 100 by 3 power 4. Therefore, q equal to 3 power 4 is not of the form 2 power n 5 power m. So denominator cannot be expressed as 2 power n 5 power m. It is not in the form of 2 power n 5 power m form. It is not in this form. 3 power 4 cannot be expressed in the form of 2 power n 5 power m. Then what will be the conclusion? So by theorem 1.5, we can conclude that 100 by 81 is a non-terminating non-terminating recurring decimal. So this statement is given by theorem 1.5. Students must write the statement of theorem 1.5 here. So let us discuss this problem again. So the problem is 100 by 81. It is given that 100 by 81. So let us take this as x. X equal to p by q, that equal to 100 by 81. Now we find the prime factors for 81. Prime factors for 81, so we got 3 power 4. So this is equal to 100 by, that is given number can be written as 100 by 3 power 4. 3 power 4 cannot be written in the form of 2 power n 5 power m. 3 power n cannot be written in the form of 2 power n 5 power m. So what we can conclude is 100 by 81 is a non-terminating recurring decimal. This is by the statement of theorem 1.5. This is by the statement of theorem 1.5. Now we consider another problem. This is the fourth problem. 41 by 75. So let x equal to p by q, that equal to 41 by 75. Now we find prime factors for the denominator q. We consider q. 75, 3 25s, 5 5s. So 75 is equal to 3 multiplied by 5 square. Now it is very clear that it is not in the form of 2 power n 5 power m. The denominator is not in the form of 2 power n 5 power m form. So this is not in the form of 2 power n 5 power m. This is equal to 41 by 3 multiplied by 5 square. Now we write the reason. Q equal to 75, that equal to 3 multiplied by 5 square is not of the form 2 power n 5 power m. We should have 2 power n 5 power m only in the denominator. So q is not in the form of 2 power n 5 power m. When it is not in the form of 2 power n 5 power m, then what will be the conclusion? By theorem 1.5, we can conclude that 41 by 75 is a non-terminating decimal and it is a recurring decimal. Therefore, 41 by 75 is a non-terminating recurring decimal. So what is the reason behind this one? This is theorem 1.5. Students must write the statement of theorem 1.5. Once again, I am repeating this. The given number is taken as x, that equal to 41 by 75. Now we find the prime factors for 75. Prime factors for 75, we can write 75 as 3 multiplied by 5 square. This is not in the form of 2 power n 5 power m. It is not in the form of 2 power n 5 power m. When the denominator value is not in the form of 2 power n 5 power m, then by theorem 1.5, we can state that the given number x equal to p by q, when it is not in the form of 2 power n 5 power m, is a non-terminating recurring decimal. So this is without actual division. We should not do the actual division. Now we start exercise 1.3 after doing some problems. Write the decimal expansion, the decimal expansion of the following rational numbers, of the following rational numbers, of the following rational numbers without actual division. Without actual division. So the first problem is 35 by 50. So again the decimal expansion, we have to write the decimal expansion of the following rational numbers without actual division. We did some problems based on this model. So this is equal to, we can find the prime factors for 50. 225s, 5 5s. So we can write 35 by 50, not 50, 35 by we find prime factors for 35 also. 35, 5 sevens. So 5 multiplied by 7 divided by 2 multiplied by 5 square. This is equal to 7 by 2 multiplied by 5. This is equal to 7 by 10 equal to 0.7. So we should not do the actual division. Without actual division, by converting the denominator, in the form of 10 power n, we have to convert the denominator in the form of 10 power n. So by converting the denominator into the form of 5 power 10 power n, we have to find the decimal expansion. So this is the problem. 35 by 50. 35 can be written as 5 multiplied by 7. 50 can be written as 2 multiplied by 5 square. After cancellation, we get 7 by 2 multiplied by 5. So 2 multiplied by 5 is 10. Therefore, 7 by 10 equal to 0.7. This is how, without actual division, we converted the given rational number p by q in the form of a decimal number. Now we consider next problem, second problem. Now we consider 21 by 25. This is second problem. This is equal to 21 can be written as 3 multiplied by 7. This is 5 square. Yes. Now the denominator has 5 square. We must get the form 10 square in the denominator. So 5 square must be multiplied by 2 square. When we multiply by 2 square, we get the denominator in the form of 10 square. So 3 multiplied by 7 by 5 square multiplied by 2 square divided by 2 square. This is equal to 3 multiplied by 7 multiplied by 4 divided by 10 square equal to 21 fourths. It is 84. 84 by 10 square equal to 0.84. We have not done the actual division here, but what we have done is we converted the denominator in the form of 10 power n. Denominator should be converted into the form of 10 power n. By converting the denominator into the form of 10 power n, we can find the decimal expansion for the given rational number, which is given in the form of p by q. So this is how we converted the given rational number into the form of p by q without actual division. This is what you must understand. All students must learn this process. Now we consider next problem. Third one, 7 by 8. This is equal to 7 by 2 power 3. Now our intention is to get 10 power 3 in the denominator. So 2 power 3 multiplied by 5 power 3. So by which number we should multiply 2 power 3 to get a 10 power 3 form? By 5 power 3 we must multiply. So 7 by 2 power 3 multiplied by 5 power 3 by 5 power 3. So if we multiply and divide by 5 power 3, then we get the form 7 multiplied by 125 by 10 cube by 10 cube. Again 7 multiplied by 125, it is 875. 875 by 10 power 3. So this is equal to 0.875. Remember, we have converted the denominator into the form of 10 power 3 by converting the denominator into the form of 10 power 3. We got the answer. This is without actual division method. Now we start exercise 1.3 of page number 12. Exercise 1.3, real numbers. Real numbers, page 12. So first problem, write the following rational numbers. Write the following rational numbers in the decimal form, in the decimal form, and also state and also state which are terminating, which are terminating, and which have non-terminating, non-terminating repeating decimal. Repeating decimal. So the first problem is 3 by 8. The first problem is 3 by 8. So it is not mentioned that we should not divide. So actual division can be done. It is okay. 3 by 8. So in this statement, the following rational numbers in the decimal form, and also state whether it is terminating or non-terminating recurring decimals. We have to give the we have to find. So it is not mentioned anywhere whether we can divide or we need not divide. It is not mentioned. We can follow any of the methods. So 3 by 8. 0, 0, 0, 0, 0, like that one we can write 0.3 24 60 7 56 40 5 40. So this is 0. So 3 by 8 equal to 0.375. 3 by 8 is a not 3 by 8, 0.3 by 0.375. 0.375 is a terminating decimal. We can write this. This is method 1. This is method 1. That is, this problem can be solved by actual division. So this is by actual division. Now we can solve the same problem without actual division. This is method 2. 3 by 8 equal to 3 by 2 power 3. Now we want to get 10 power 3 in the denominator. So to get 10 power 3 in the denominator, we must multiply 2 power 3 by 5 power 3. So to get the form, this one, 10 power 3, we must multiply by 5 power 3. So this is equal to 3 by 2 power 3 multiplied by 5 power 3 divided by 5 power 3. By doing this, there will be no change in the value of the given number. This is equal to 3 multiplied by 125 divided by 10 power 3. This is equal to 375 divided by 10 power 3 equal to 0.375. So students can solve answer to this problem in both the ways, because it is not given by which method you have to find the answer. Now we consider the second problem. We consider the second problem. 229 by 400. 229 by 400. So this can be written as 229 by 4 into 10 square, that is 100. 4 into 10 square. So we divide 229 by 4. 4 5s 20, 2 9, 4 7s 28, 1.02, 8s 2, 0, 5s 20, 0 we get. So this is equal to, the value of this is 57.25. 57.25 divided by 10 square. This is equal to 0.5725. 0.5725. This is method 1. This is method 1 by actual division. By actual division. So this is a division method. This is division method. And now students can answer to this question without actual division. Students can answer to this question without actual division. What you can understand from this is a problem can be solved by different methods in mathematics. 229, this is method 2. Method 2, without actual division. Without actual division. Two 29 by 400. This is equal to 229 by 4 multiplied by 100. This is equal to 229 by 2 square multiplied by 10 square. So now we have 2 square in the denominator. It should be converted into 10 square. 2 square must be multiplied by 5 square. 2 square must be multiplied by 5 square. To get the form 10 square. So this is equal to 229 by 2 square multiplied by 10 square multiplied by 5 square by 5 square. So combining these two, what we get? We get the form 10 square. So 229 multiplied by 25 by 10 square multiplied by 10 square. So this is equal to, you have to find 229 multiplied by 25. This is equal to 5725 divided by 10 power 4. Therefore, we can write it as 0.5725. So this is by actual division method. Without actual division, we can answer to this question. So if in the examination, the question is given as to find the decimal expansion without actual division, you can follow this method. Or if the question is simply find the decimal expansion, you can follow either of the two methods, the first method or the second method. Now, we solve the third problem. Third problem, 4 1 by 5. A mixed fraction is given. So when a mixed fraction is given, we can convert into improper fraction. 4 multiplied by 5 is 20 plus 1. So 20 plus 1 by 5 equal to 21 by 5. Therefore, this is equal to 21 by 5 multiplied by 2 by 2. Why should we divide and multiply by 2 by 2? Because we want to get the form 10 in the denominator. We have 5 in the denominator, so we must multiply by 2. So this is to get the form 10 power n in the denominator. So we get 42 by 10. This is equal to 0.42. This is without actual division. Without actual division. So this is actually method 2. I did the problem by method 2. Now method 1. Method 1 is by division. By division. So 4 1 by 5 can be written as 21 by 5. No, we have to write this not. This is 4.2. This is 4.2. 4.2 is the answer. 4.2. Not 0.42. It is only 10, 42 by 10. So this is equal to 21. So we have to divide by 4. 20, we get 1. We keep decimal, so 10. 2 is 10, 0. So this is 4.2. So students can solve this by either of the two methods. Now we consider the next problem. Right. So here we have to write that it is a terminating decimal. It is a terminating decimal. 0.375 is a terminating decimal. And here also we must write 0.5725 terminating decimal. It is a terminating decimal. So here also we must write terminating decimal. And 4.2, it is also a terminating decimal. Terminating decimal. Here also we must write terminating decimal. So it is asked in the question whether it is a terminating decimal or a non-terminating recurring decimal. So we must state this, whether it is a terminating decimal or non-terminating decimal. Now we consider the next problem. Fourth one, 2 by 11. True 0.00000 and so on. 11. 11 once 11 we get 9, 0. 8s, this is 0.18. 8, 8, again 2, 0. Once 11, 9s, 9, 0. 8s, 88, 2 and so on. So finally what we get is 0.181818 and so on. So this is equal to 0.18 bar. So it is a non-terminating recurring decimal. Non-terminating recurring decimal. Because we are getting 2 again. 2. So the same gets repeated. It is not 0.18. It is 0.18 bar. Students must understand the difference. 0.18 means it is a terminating decimal. 0.18 bar, it is not a terminating decimal. It is a non-terminating decimal and a recurring decimal. Now, by method 2, we can state that it is a non-terminating decimal. It is not in the form of 2 power n, 5 power m. 11 is not in the form of 2 power n, 5 power m. So it is a non-terminating recurring decimal. We can simply say that. Now we consider another problem, fifth problem. Eight by 125. This can be written as 2 cubed by 5 cube. So 8 equal to 2 multiplied by 2 multiplied by 2. 125 equal to 5 multiplied by 5 multiplied by 5. So now we follow method 2. This is by method 2, that is without division. This is equal to 2 power 3 by 5 power 3 multiplied by 2 power 3 and divided by 2 power 3. This is to get the form 10 power 3 in the denominator. To get 10 power 3 in the denominator, so 5 power 3 multiplied by 2 power 3 should be there in the denominator. So the given number is multiplied and divided by 2 power 3. So this is equal to 2 power 6 by 10 power 3. So 8 multiplied by 8 is 64. 64 by 10 power 3, that equal to 0.064. It is a terminating decimal. It is a terminating decimal. Why? Because the denominator 5 cube is of the form 2 power n 5 power m. When the denominator is in the form of 2 power n 5 power m, we get a terminating decimal only. We get a terminating decimal only. This is method 2 without actual division. This is without actual division. Now method 1. Method 1, it is by actual division. 8 by 125, we can do the division for this. So 8.00000 and so on, I can write 125. 125, so 0.6 times. 6 times 125. 600 plus 150, 750. 750. Again we get 500. So it is 4 times we get 500. So 0. So 0.64. It is a terminating decimal. Terminating decimal. So students must adopt the right method depending upon whether you should do without actual division or you can do by division, actual division method. So depending on the nature of the question, students must answer to this problem. Now the second problem, second Roman. In this second Roman, without actual division. It is strictly without actual division. Second Roman, without performing division, without performing division, state whether the following rational numbers, state whether the following rational numbers will have a terminating decimal form, will have a terminating decimal form, or non-terminating decimal form. So, in this problem, it is clearly mentioned without performing division. We must state whether it is a terminating decimal or non-terminating decimal. Non-terminating repeating decimal. Repeating decimal form. So again, we must understand that if the number is of the form, x equal to p by q, where q is in the form of 2 power n 5 power m, it is terminating decimal. It is if q is not of the form 2 power n 5 power m, then x is a non-terminating decimal, repeating decimal form. Repeating decimal. So all students must remember this. If the given number is of the form p by q, x equal to p by q, and q equal to 2 power n 5 power m, then it is a terminating decimal. This is first one. The second statement is if q is not of the form 2 power n 5 power m, if the denominator is not of the form 2 power n 5 power m, then x is non-terminating repeating decimal. So this is what you must understand. The first problem is 13 by 3125. Now I find prime factors for 3125. 3125, 5s, 6, 2, 5. 5 125s, 5 25s, 5 5s. So this is equal to 13 by 5 power 5. Now this can be written as 13 by 2 power 0, 5 power 5. So this is of the form x equal to p by q and q equal to 2 power n 5 power m form. So we have written 2 power 0, 5 power m. And hence what we can conclude is that 13 by 3125 is a terminating decimal. Therefore, 13 by 3125 is a terminating decimal. So because the denominator is of the form 2 power n, 5 power m. 5 power 5 can be written as 2 power 0, 5 power 5. So this is what you must remember. Now we consider the second problem. Eleven by 12. Second problem, 11 by 12. This is equal to, so x equal to p by q equal to 11 by 12 equal to 11 by 2 square multiplied by 3. So q is not of the form 2 power n, 5 power m. Therefore, q means denominator. Here q equal to 12 equal to 2 square multiplied by 3. So therefore, 11 by 12 is a non-terminating recurring decimal. Recurring decimal form. So 11 by 12 has a non-terminating recurring decimal form. Now we can, so students must remember again, when the given number is taken as x equal to p by q and q is not of the form 2 power n, 5 power m. If it is not of the form 2 power n, 5 power m, we get a non-terminating recurring decimal form. Now we consider the next problem. Third one, 64 by 455. So now we find prime factors for 455. 455. So I take 5 nines, 5 ones. Again 7 13s. This is equal to, so x equal to p by q equal to 64. We can write prime factors for 64, but it is not necessary and mandatory. So 32 to 16s to 8s to 4s to 2s. So this is equal to 2 power 6 by 5 multiplied by 7 multiplied by 13. Q equal to 5 multiplied by 7 multiplied by 13 is not of the form 2 power n, 5 power m. Since q is not of the form 2 power n, 5 power m, then 64 by 455 has a non-terminating recurring decimal form. So this is our conclusion. So when the denominator q is not in the form of 2 power n, 5 power m, then we immediately conclude that it is a non-terminating recurring decimal form. It has a non-terminating recurring decimal form. Now we consider another problem. Fourth one, 15 by 1600. This is equal to 15 can be written as 3 multiplied by 5, 16. So we can write prime factors for 16. This is 2 power 4. 100 equal to 2 square multiplied by 5 square. So this is 16 multiplied by 100. We can write 3 multiplied by 5 by 2 power 6. 2 power 6 multiplied by 5 square. Otherwise, we can do the prime factorization method, 1600 to 800s to 400s to 200s to hundreds, 2 multiplied by 50, and again 2 multiplied by 25, 5 multiplied by 5. This is how we can find the prime factors. 2 power 6 multiplied by 5 square. So this can be written as 3 by 2 power 6 multiplied by 5. So I can write x equal to p by q, that equal to 15 by 1600 equal to 3 by 2 power 6 multiplied by 3 by 2 power 6 multiplied by 5. Now what I can conclude is that q is of the form q equal to 2 power 6 multiplied by 5 is of the form 2 power n 5 power m. Therefore 15 by 1600 has a terminating decimal form. Why? Because the denominator q, which can be expressed in the form of 2 power n 5 power m, because it is q equal to 2 power 6 multiplied by 5. So we can write it in the form of 2 power n multiplied by 5 power m. Hence, it has a terminating decimal form. Now we consider the next problem. Fifth problem, 29 by 343. So let x equal to p by q, that equal to 29 by 343. We can find prime factors for this. 749s, 7 sevens. So this is 7 cube. So q equal to 7 cube is not of the form 2 power n 5 power m. That is the denominator 343 cannot be expressed in the form of 2 power n 5 power m. Therefore we get Therefore, 29 by 343 is a non-terminating recurring this has 29 by 343 has a non-terminating recurring decimal form. So again, students must understand that 7 power 3 cannot be expressed in the form of 2 power n 5 power m. It cannot be expressed in the form of 2 power n 5 power m. Therefore, we conclude that 29 by 343 has a non-terminating recurring decimal form. This is by theorem 1.5. Now we consider another problem. Sixth problem. 23 by 2 cube 5 square. X equal to P by Q equal to 23 by 2 cube 5 square. Q equal to 2 cube 5 square is of the form 2 power n 5 power m. Therefore, 23 by 2 cube 5 square has a terminating decimal form. So it is already given in the problem that 23 by 2 cube 5 square. We need not find prime factors for the denominator value. It is already given. When it is already given, we can just verify whether it is in the form of 2 power n 5 power m form. If it is in the form of 2 power n 5 power m, then the given number has a terminating decimal form. If it is not, if the denominator is not of the form 2 power n 5 power m, then we conclude that the given number is a non-terminating, non-recurring decimal number. Now, seventh problem. 129 by 2 square 5 power 7 7 power 5 x equal to p by q, that equal to 129 by 2 square 5 power 7 7 power 5. Q equal to 2 square 5 power 7 7 power 5 is not of the form 2 power n 5 power m. We must have only 2 power. So this is not of the form. Why? Because, what is the reason? Because we have 7 power 5 also. Since there is a 7 power 5 also in the denominator, it is not of the form 2 power n 5 power m. We conclude that. Therefore, 129 by 2 square 5 power 7 7 power 5 has a non-terminating recurring decimal form. Why? Because 2 square 5 power 7 7 power 5 is not in the form of 2 power n 5 power m. So this is the reason we conclude that the given number, rational number, is a non-terminating recurring decimal. Now, we consider the next problem. We should not have any other numbers other than 2 power n and 5 power m. We must have 2 power m in the denominator. We must have 2 power n, 5 power m only. There should not be any other numbers. If there are any other numbers, then it is a non-terminating decimal. You must understand this. Now, so eighth problem, 9 by 15. This is equal to 3 multiplied by 3 by 3 by 5. This is equal to, on cancellation, we get 3 by 5. So, x equal to 9 by 15 equal to 3 by 5. This is equal to P by Q form. So, Q equal to 5 equal to 2 power 0, 5 power 1 is of the form 2 power n, 5 power m. Therefore, 9 by 15 has a terminating decimal form. So this is why, because 5 can be written as 2 power 0 multiplied by 5 power 1. So this is the reason we can conclude that the denominator is of the form 2 power n multiplied by 5 power m. So it has a terminating decimal form. Now we have only 2 problems. We will complete these 2 problems today, and tomorrow we will consider the next model. Now, ninth problem, 36 by 100. 36 by 100. So x equal to 36 can be written as, we find prime factors, 2 18s, 2 9s, 3 3s. So 2 square multiplied by 3 square by, so 10 equal to 2 multiplied by 5, 10 square equal to 2 multiplied by 5 whole square, that equal to 2 square multiplied by 5 square. So denominator can be written as 2 square multiplied by 5 square. On cancellation we get, this is equal to 3 square by 5 square. Now this can be written as 3 square by 2 power 0 5 square. 2 power 0 5 square. So x equal to P by Q implies Q equal to 5 square is of the form 2 power n 5 power m. Why? Because we can express 5 square as, so Q equal to 2 power 0 5 square. Therefore 36 by 100 has a terminating decimal form. So now we consider the last problem today. 10th problem, 77 by 210. So x equal to P by Q. This is equal to 77 by 210. 77 can be written as 7 multiplied by 11, and 210. 210 we find prime factors. 2, 105, 3 35s, 5 sevens. So 2 multiplied by 3 multiplied by 5 multiplied by 7. Now we strike off the common factors. We get 11 by 2 multiplied by 3 multiplied by 5. So Q equal to 2 multiplied by 3 multiplied by 5 is not of the form 2 power n 5 power m. It is not of the form 2 power n 5 power m. So why? Because there is 3. 3 is in the denominator. So it is not of the form 2 power n 5 power m. Therefore, what we can conclude is that 77 by 210 has a non-terminating recurring decimal form. Non-terminating recurring decimal form. Students, tomorrow we continue the models 3 and 4. Page number 13. Page number 13, we continue the problems 3 and 4. And what I suggest to all the students is for real numbers, practice is a must and should. You go through the previous problems. If you get any doubts in the previous problems which we have discussed earlier, you send your doubts to my email. I will answer to your questions through email, and also I will check your notes also if you send your notes to my email, and I will upload today's class notes in WhatsApp resources. Thank you all students. Thank you very much. Once again, I tell you to concentrate on mathematics from the starting of the class. So we start the class exactly at 5:30, 5 o'clock. From 5 to 6:30 we continue the class. Tomorrow also we attend at the same time. Thank you very much. Thank you all students.